The next generation science standards are being widely adopted throughout the United States and reflect a major change in our paradigm shift in the way we think about science education. When you click on the next generation science standards page, you will be able to get tremendous amount of information about the standards. And they're arranged by disciplinary core idea and topics and so forth. And so if we look at core idea right here, we can see that you could go to any particular grade level or look at any particular topic. Let's say we were looking here for high school and we're looking at, let's say, biology, and we can see that if we want to look at the ecosystems one, so here we can look at high school life science level 2 here, ecosystems, and this will be a set of the actual standards in the next generation science standards. So it's a fairly daunting document here, and you can see it's broken down into these disciplinary core ideas, which is illustrated in orange, surrounded by science and engineering practices and cross-cutting concepts that have applications across all fields. And so when you look at any of the disciplinary core ideas, there will be both the science and engineering practices on one side as well as the cross-cutting concepts on the other side. So looking at the way that the NGSS is designed, there are three major dimensions. We talk about the core ideas, which would be consistent with what most people think in terms of standards. Now, this is kind of the content of life science, the content of engineering, technology, and physical sciences and earth and space sciences. But then there's also these practices. This is the science and engineering practices and the cross-cutting concepts that have applications across all fields. And while this content here remains pretty consistent from previous standards that states have adopted, the emphasis up here on the science and engineering practices, as well as the emphasis on these cross-cutting concepts, is new for most states. And so we want to give some attention to this, particularly as we talk about CSCS, in other words, computer-supported collaborative science, and how it might assist in addressing NGSS. And we're going to focus up here on the science and engineering practices, Dimension 1, because we believe that the CSCS model is an extremely good model for addressing these various areas. In other words, how to ask questions. That would be kind of a scientific principle. How do we ask good scientific questions? How do we define problems for engineering? How do we use models, whether they be models to explain like a biochemical pathway in science, or a model to design a circuit board in engineering? How do we conduct investigations? How do we basically test some kind of hypothesis and come up with some kind of conclusions for science? Or how do we go through the iterative process of designing something to meet a defined problem in engineering? How do we look at the data? In other words, how do we look at the data for science when we're looking at this and seeing does our hypothesis jive with the data? Or maybe we're looking at design in the engineering concept in here, and does the data we can analyze about our design actually coincide with our particular problem that we're trying to address? How do we use mathematics? Again, you'll see this with the Common Core, which preceded the NGSS. But mathematics should be integral to everything we're doing in science. It shouldn't be a separate field. It should just be assumed that we're using mathematical principles in all that we're doing as it's applicable. How can we construct explanations? That would be, again, in a scientific issue. In other words, is that, okay, we have a hypothesis and we've analyzed the data, we've used mathematics and so forth to come up with hopefully some good analysis, and now can we come up with some kind of an explanation. And in engineering, we would design some kind of solution to the problem, again with an iterative process, going back there and refining it as necessary to come up with hopefully the best solution. And finally, can we argue from evidence? So that is our explanation based upon evidence? Is our solution based upon the evidence and so forth, having analyzed the data using mathematics and so forth? And after this whole process is completed, do we communicate that information? Now, CSCS addresses all of these components really well in the science and engineering practices of the NGSS. The content, of course, any content can be used in a CSCS environment. And these cross-cutting concepts also can be very well addressed in the using of CSCS. So CSCS is a methodology which we believe particularly does a great job here in addressing the science and engineering practices required by the NGSS. And of course, any of the other content, the core ideas, can be would be the focus of any particular CSCS lesson. And we can, as a teacher and using CSCS techniques, we can show how these concepts apply across these areas. So for example, how does energy, in the form of ATP in life sciences relate to energy that we're talking about in running machines and so forth, which we talk about energy in terms of the solar system and solar energy and so forth, or energy in a physics sense or chemistry sense in terms of measuring the caloric content of something. The idea is that these concepts will apply across all of these disciplines right here, and we will use these practices to try to get to those core ideas, and particularly to the concepts that have applicability across all those fields. So in this activity, we'll be looking at how CSCS can focus particularly on addressing the science and engineering practices required by the next generation science standards.